Muted. I've just now started the recording of this. Today, we are definitely going to engage you, hopefully. And the topic we are talking about is demonstrating voltage drop with using someone else's hands, which is pretty relevant here in our distributed learning environment that we're in. So I'm kicking this right to Jeff, but as he asks questions and asks things of you, you can put them right here in the chat window and I will be your voice for you. Okay? Take it away, Jeff.
Okay, sound check. You hear me okay? Okay.
Yes.
I'm Jeff Curtis, Council Lab. We've been doing this for a few days and we've had a lot of questions about our setup. How would we actually deliver this? And, we are planning just in time. We planned, started at 7:15 my time in Pacific here this morning. We've put this together pretty loosely and we're pretty excited to show it to you. But we also require some feedback. So what's going to happen here, the setup is that I am the teacher with the hands and my students are going to guide me with a piece of equipment. So we're going to push some simple schematics to you. This is really the very basics of what we can come up with on spur of the moment with showing an electrical lesson. So with that, and at the end,
I was just going to say, of course, it's more about the concept of engaging students, not the lesson itself. So,
well, yeah, it is to concept to engage. And I will show you my setup in the end here, how I've actually done it. But bear with me a second. Maybe somebody else could talk while I get this screen shared.
I'll jump in for 1 second. I said it earlier, but for those who just joined us, while we are demonstrating this using our CL 1919 Ohms Law Trainer, this is not a sales presentation. We are not here to sell you this product. We're here to demonstrate it. We had it at our hands, so that's the one we're using. Do not worry if you're expecting or thinking this might be a sales pitch. It will not.
So on the screen, what we've set up is, like Jimmy said, our Ohms Law Trainer, and we're going to go through some basic testing. Now, I'm going to have Tim and Rick lead me through some questions, and or the rest of you lead me through some answers as well. So, Tim wanted me to ask, what are the 5 components required to build a circuit? And if you could reply in the chat, that would be great. And then I'm going to have Tim and Rick. We're going to pause for maybe a few seconds, and then we're going to move on. So what are the 5 things required to build a circuit?
So Josh says power source.
Okay, power source.
Ed says ground. John says load. We've got several loads.
Okay.
Power, ground, load, and conductors.
Conductors, okay.
And we've got control.
Okay, cool.
Power source, load, switch, fuse, and switch. So we've got a fuse now.
There we go. Those are the 5 things we identified. You've called them something different every once in a while, but that's fine. We got a power source, protection, switch, load, and conductors. So what are the steps to build the circuit? So I've got this stuff all set out here. What are the steps? Maybe you could throw up take my screen away and throw up the schematic for a minute, or put the schematic in the chat.
I was just going to throw it in the chat.
Yeah, that'd be better. So
in the chat now, there should be a simple circuit.
Joe Hart says you need to start with the power supply.
Okay.
Yep.
So tell me what to do, Joe. What do we need to do with the power supply?
Remember, all of you instructors in the chat, you are actually the students. in this scenario.
Yes. Yes.
So get off Facebook and give us an answer.
Connected to the
Joe
fuse
says
and then the
connect it to the
switch.
fuse and then the switch.
Connect it to the fuse and then the switch. So I've just put my meter here and here.
What are you connecting?
Well, he said to connect between the fuse and the switch. So this is between the fuse and the switch.
Dan says connect power to fuse with a wire.
Oh, connect the power to the fuse with a wire. Okay. Here's a red wire. I'm going to go up here. I'm going to connect power to the fuse. Okay.
Joe had a question of what is it that you want to measure?
Well, good point. What we're going to demonstrate is the circuit that's in the chat. So we're going to hook that up. And then we're going to get on with the lesson. It's all part of the lesson. So I've got a red wire from the power to the fuse. What's next?
Joe believes the way your meter currently is will measure amperage.
Well, that was the way he had it.
So you probably can't see close enough, but it is actually in the 20 volt range. I would normally have this off, but this meter fires up right off the bat. So I've just left it there. But what else do I need to make this circuit work?
Switch L1A.
Switch to, okay, well, I've got this wire in here, so I'm going to switch to L1A.
And then L1B to ground is what Josh Finley says.
Okay, L1B to ground. Okay, is that all I need?
Fuse to switch.
Oh, we got to hook from fuse to the switch, don't we? Okay. Switch is off. Now what do you want me to do?
All depends on where your switch is in the series circuit, is what Franco just said. Joe wants you to turn on the switch.
Turn on the switch?
Yeah.
Are we ready to turn on the switch, everybody?
What happens if you do turn on the switch?
Oh, okay. Well, we shouldn't we? So let me move this wire out of the way here, and because I want to, you have to be careful, observant to see the bulb. Okay, and it's going to be right up under my finger, and I am going to dismiss this, and then I'm going to turn the switch on.
Richard Smith is afraid you're going to let the smoke out.
So I turned the light bulb on. Okay, I don't know if you can hear the click of the switch, but I think everything is a clue in troubleshooting. So I on, and I get a slow response, and it doesn't look to me like that bulb's really illuminating very well. What should I do?
I hear somebody typing. That's a
So
good thing.
I'm going to drink my tea while you students are.
Joe
thinking.
would like you to voltage drop the power side.
Okay. So what does that mean, Joe? Where do I?
And Marshall suggests you start taking some voltage readings.
Okay. Can I just, how about if I take the voltage reading between my two hands? I don't seem to be, well, by golly, I got 2 millivolts or 20 millivolts there. I'm getting a charge out of this
You're
class.
up for voltage.
But you're negative instead of positive, though.
Yeah.
It's the times we live in.
Yeah, it's the times we live in. So what?
Red probe at battery, black at the other end of the first wire coming from the battery source.
So does that mean down here in the ground bus? Okay, we've got this. I'm going to hook my black lead there. Okay, Now what do I do?
He said put the red at the battery source.
Yeah, I said put the red probe at the battery source.
Oh,
and
the
then
battery
black
source.
probe at the other end of that first wire, which would be
Okay,
the coming out of the fuse.
Yeah, okay, thanks, Marshall. And for our intents and purposes, this is our battery source. Now, before I do that, this is it's not a trick question, but what should I expect to see?
Corey says voltage drop across the fuse.
And
I think that
I'm going to follow this. I'm going to follow this first instruction as to check the source voltage. What should I see?
0.05 or less.
So I'm going to see 0.5. I'm going from battery negative to battery positive, and I should see 0.05 or less.
I think the chat's mixing up some of the measurements.
So
The
I'm merely going to check source voltage right now.
got it.
What would I expect to see?
It should be 12 volts.
So can we agree in chat? Should we see 12 volts or something that looks like 12 volts?
Yes, everyone's agreeing to that in the
Okay,
chat.
cool. I'm going to be tedious about this because I want you to think about it. Because you're the students, right? So
Right.
I want you to tell me exactly.
All of your students appear to be on the same page. There should be between 12 and 13.
Good. Well, now before I do that, let me make a point. You need to be able to see the chat while you're talking, and I'm not going to do that. Jimmy's my chat in my ear, so you'll have to figure out your own strategies. So if I hook this up, you all are saying that our source voltage should be 12 volts or something that looks like 12. So, okay.
And should be checked before any diagnosing should be done on any car. Just a good point.
Let me make sure that
Joe Hart is having fun, and that's good because learning should be fun.
So there, can we see on the meter, we've got 11.9 volts.
So we're right where we should be.
Yeah, 11, 12. Nominal. We call that nominal, right? Nominal voltage. For our intents and purposes here, that's not a fully charged battery, but it should be able to make that light work properly, right? So now that we've established that we have source voltage, what's next?
Richard Smith says, turn the switch off.
Turn the switch off. Okay. Next step.
He says, now verify your voltage.
Verify my voltage. So we would call it, well, there's a term for this. I've got 1345. There's a term for this.
Jay says, test the wires.
Test the wires.
How test and what wires?
I knew Jeff was going to say that. Is there a lag in the bulb illuminating, or is it my connection?
No, there is a lag. Yeah, that's great. I think that from a student, that's a great connection. So let me turn that on again, and we'll look at the bulb, and I'm on, and very slowly it comes up, Jay. Very slowly, and it's dim.
Josh says, move DVOM red wire to the L1A pin.
Ooh. Okay. Now, when we do that, I'm going to keep asking these questions. And I learned this from Tim Dwyer. So Tim always, and he's very adamant about it, and I think he's absolutely correct. Before you hook that wire up, what do you expect to see there?
talk about this quite a bit, Jeff, in our travels, which is the
Source
difference
voltage.
between somebody who just, talks about, hooking up a meter and just simply reading the meter versus somebody who has a predictive outcome for everything that happens. So I'm very glad you're doing this part.
Source voltage is what your students are saying. We're just less than source voltage.
Yeah.
Okay, something that looks like 12 volts. Okay, that's what I was waiting for. So you want me to do the positive side first? And I'll do that. Tell me your assessment of this. What does this mean, this reading, and what should we do next?
There's a problem on the positive side circuit. There's resistance there.
Okay. So,
Lots are saying there's voltage drop going on the positive side.
okay. So, if we were in a teaching moment here and I was the teacher, which German could I make a reference to here?
Oh, that's funny.
And which one are we? I mean, what are we establishing?
You stumped him with the German question.
Well,
Josh says you should now move the DVOM red wire to the right side of the switch.
the right side of the switch. Okay. So that means I've taken my red wire and I'm going to go down here, right? Is that where you want, Josh? You're sure?
Yes, he says yes.
Okay. I'm just being I'm just being me, right? What? Oh, wait a minute. What do we expect to see here?
Yeah.
What do we expect to see here?
Source.
Okay.
Okay, source or something that looks like source, right? So here we go. Give me your assessment of what we've just done.
I knew that was coming.
Joe wants to know what's under the cloth. That's hashtag what's under the cloth.
Pay no attention to the man behind the curtain.
Yeah, there you go. So
It's the Wizard of Ohms.
well, I think it's the Wizard of Kirchhoff, but
The magic claw.
the magic cloth.
That's pretty good.
Okay, so
Richard Smith says the fuse and the switch appear to be fine.
Perfect. That's a great observation.
Yep.
Jimmy, read what Marshall said, because Marshall's giving away the.
Marshall said if you had faulted wires, there would be no visual clue to point that out.
No, up from there. He says, for those that are familiar with the board, paying close attention, they may realize that the wire is most likely running through something under the rags.
Okay.
So Josh says, as a student, he says, replace the wire between switch and L1 bulb.
Oh, that'd be a simple thing to do, wouldn't it? So couldn't I just go, say, from the switch? I'm going to keep let's take the
Joe Hart likes what you just said about Kirchhoff.
Yeah. Okay. So I'm going to bypass this wire because the rags represent, to me, our vehicle. It's under the dash, or it's on the way to the tail light. It's on the way to the side marker that we're turning on. This is a very low wattage and has a low intensity. But this is one of our problems. We got a dim bulb, and he's not necessarily sitting in the front row of class.
Yeah,
we have to find it. So this is just going to verify our findings that we already had at the meter, right? So let's go ahead and do that. What do we expect to happen now before I hook this wire up? I'll just take this wire out of play completely. Let's put it off to the side. And I'm going to hook from here, and I'm going to hook up to here. What should happen?
You should expect source volt at the bulb and a brighter bulb.
Okay, let's do that all at once. Then I'm going to hook my lead in. These leads are stackable. They're really quite convenient to do this with. I'm going to move my, so I've got source voltage, right? Because I've hooked in here. And I'm going to hook this up, and everybody says that we're going to have a bright bulb. Correct?
Yes.
Okay, I'm being very tedious on purpose, right? So hook that up, and there would blast your eyes out, right?
Definitely. Richard Smith said it also shows the ground circuit is good.
Yes.
How could we have tested that before we even did anything?
Let me ask this question, Tim.
Check for 0 volts on the ground side of the load.
Okay. That's good.
And Richard
gets a
ohm
gold
the
star.
wire circuit. Ohm it.
Ooh.
Yeah, probably not likely I'm going to do that. Do you have a specification for the ohms? And is anybody going to go look it up?
One
Yes,
of your
Mike,
Mike,
go ahead, Mike.
go to the bathroom.
I think Mike's going to go look it up.
Mike Hagan would like to go to the bathroom.
Oh, that's okay, Mike. Be sure to flush and wash your hands.
Give him the big piece of wood with the key on it.
Yes. So when I hook this, I want to make a point up here as well.
And Joe Hart says your ohm meter could lie.
Yes, in ohms. So I want to make a point of what I get here. So when we hook this up, what do we expect here? Now we've got a fully working circuit that looks pretty darn good, right? I mean, the intensity of the bulb, I would say to my students looking from afar that this is a properly working circuit. But before I hook that ground up, what's the meter going to show?
What's the voltage reading on the ground side of a load?
What's the voltage reading on the ground side of a load of a functioning circuit?
Source without the ground connected.
Source
200
without
200 millivolts or MVs.
Ish.
So we're going negative to negative. We want to see something that nominally looks like 0, right?
0-ish is what Marshall says.
0-ish. I like that. That's a very technical term. I'm making a point here. So I'm going to switch to the 2-volt scale. I'm going to switch to the 200 millivolt scale. And I'm going to scale down until I have a legible reading of 3.2 millivolts. Now, for demonstration purposes, when I turn this light switch off and the bulb goes out, what's going to happen to this figure?
It should get a source, right?
Jeff, you're up on your 5 minutes.
Yeah, thanks. But I want this one first. What should I see on the ground side?
Marshall says 0 volts.
Marshall's like a teacher's pet here. What's the deal?
Yeah.
I think I've seen him. I think I've seen
We
him
all
in class
know the
before.
deal.
We all know that.
Okay.
You're
So there
breaking
we
the
end
circuit
up
of
with-
voltage is what another student said. You're breaking the circuit of voltage.
Yeah. Well,
So this shows that there is current flow in the system. We might use that information for later testing for voltage drop across a fuse or any other thing in the circuit. So that's the, I go down through my list.
5 minutes.
Yep. So to bring this to closure, I think what you've demonstrated by me being your hands is that you're able to have the students be your hands and participate in what's going on here. And I would like to, for a moment, I'm going to quit sharing this screen, stop presenting.
Some wanted to see your setup. How did you
Yes.
do 2 displays?
Yep, and that's where I'm doing it. So as soon as I figure out that I am going to present my screen.
Yesterday, the guy showed you kind of ways you can use technology that you have there at your house to do things like this. So Jeff's going to show you right now exactly how he pulled it off using a phone and an iPad, I believe.
A phone and a computer and an iPad. So here's where I'm watching what's going on right here on this screen.
Okay. House of Mirrors.
House of Mirrors, yes. I'm using my phone, Android, Apple, don't matter. I mean, you can do all that. And then here's my setup over here. Let me just go up high here. So what I've done is I've just put my iPad up. I enter in Teams, I present, I turn the sound off, turn all the sounds off, because we went through that testing earlier today, and it's that echo thing is not pretty to hear. Now
we had dogs barking.
Dogs barking.
They want to see under the cloth.
Oh, I knew they would want to do that.
Come back tomorrow. Right? Hey, whoa, come back tomorrow.
Yeah. Details at 11.
But wait, there's more.
Okay, so I'm gonna get these wires out of the way. So I had to come up with a way, like Marshall said, if we had a faulted lead, which some of us have made, we could hide this a little easier. But what I'm saying is that we could also hide it in plain sight. You just have to be innovative, right? So I've run this through the resistor. Maybe a further exercise that you would want to do is calculate the dynamic resistance across this with the voltage drops we had. You could go through, if you're into calculating resistance. I'm not really. I know the relationships, so I also understand that you want to have students perhaps calculate those resistances. But
someone wants to know if that's your loincloth.
That's my loincloth? Which one?
The really small one.
Oh, yes. Yes, and in blue too. Okay.
So we have 2 minutes left. Obviously what you're looking at there is the DC circuit trainer, Ohms Law Trainer that we do offer. Again, we're not here to make a sales pitch, but it's a really fantastic product for and things like this.
And Jimmy makes a good point that you may not have this at your place. Use what you have. Do you have a meter? Are you even teaching electrical? Right?
Joe Hart said he likes to remove the ground on a turn signal circuit and let them see what diagnose goes on in that circuit and check for voltage on the ground side.
Yes. Yep. There's a lot of different strategies you could take this from, but I think also a point here is look how fast a half hour went. So
yeah, and hopefully you guys were engaged. You seemed like you were, Marshall in particular, but still.
Marshall is today's teacher's pet.
That's okay.
Yes. So where we want to spin this, I asked yesterday for answers to 4 questions, and I've gotten a couple of late replies that I haven't had a chance to read. We're using your questions to plan for our next day. So hopefully you can appreciate that this is just in time learning. We're trying to demonstrate things to you that you could use tomorrow. Hopefully you could walk out of here today, walk out of your office or wherever you're at, and to be able to implement something small to begin with. In the beginning, I showed an exercise of tire pressures. Here's an electrical one. What we would like to invite you to do next week is we'll have something for you, the rest of this week, but we're encouraging you to now go build and show us. Be innovative. Come and present in this 20 minutes